Welcome, everyone. Hopefully everyone can hear me okay. It's always terrible to be right after lunch, but please come in, get seated. Don't fall asleep, please, as we go through this. Look, a little intro on myself. I'm Sandy Bird. I'm currently the CTO and co-founder of something called Sonrai Security, which is a cloud security product. But I started my career years ago as one of the founders of Q1 Labs and QRadar, so I know an awful lot about the SIM technology and all of those as well, and have spent my whole career basically looking at security and how to secure people's enterprise data centers and now cloud enterprise data centers. There's a couple of interesting things we're going to do today, actually. We're going to spend a little bit of time talking about how when you move your workloads from your kind of on-prem data center over into Amazon or Azure or GCP, there's some interesting things that are the same, and there's some stuff that's quite different. And I think when I founded Sonrai Security, I was a little naive to some of the changes and the differences. So we'll talk a bit about those today. And then we're going to look at some ways where you can help evaluate risk in those environments and how you can solve some of these problems. This is the first thing that became so surprising for me when I started looking at when you deploy workloads into these cloud providers. And it doesn't matter which one you pick. It could be Amazon, it could be Google. The first thing is that the controls that are in them are truly enterprise grade, and you can probably do a better job securing these environments than you can your enterprise data center. And that seems wrong initially, until you realize a couple of things. The first is because all of these cloud providers have a bill associated at the end of the month, there's an API to tell you everything that's running there. And so you actually have a real-time CMDB that can never be wrong. When was the last time that happened in an enterprise data center? The second thing is that they're fairly good at auditing everything that happens, which is also a struggle in most enterprise data centers. And so because of that, when you provision identities and you give them some sort of an entitlement or a set of rights, you can actually monitor if they're using them or not. And so when you try to get to things like least privilege, you have a goal you can measure against almost for the first time. It's quite interesting in cloud. The other thing is that we've kind of turned the development teams on their heads. So before you had a network team and you had a database team and you had one team that was responsible for vulnerabilities and you had another team that was responsible for attacks. Now we actually take a team, we build the application end to end, and that team is responsible for building the architecture. They're responsible for deploying the infrastructure it runs on as infrastructure as code. They deploy the databases, they provision the identities, and they monitor it in production. All of that by one team. And so because of that, you don't have to actually look at all of the individual risks in these silos. You can look at it all together. And it's a great way to kind of see what's going on in these environments. Now, the things that's kind of interesting, and this is the shocking part, we actually monitor every single permission in every single cloud every day. And when we average that out on a year basis across 3 cloud providers, Amazon, Azure, and GCP, there are 17 new permissions a day that show up. Some of those permissions are really mundane. List buckets, great. You can get a list. It's like a directory listing. Who cares? But you can also have one, and I love this one. This is an Azure one you guys can take home. There's a permission called begin get access. What the heck does that mean? I don't know. If you do a little research, you discover that this takes a disk off of a VM and makes it a public URL. Wow. Couldn't do that in my data center ever. But yet that's one of the 37,000 unique permissions that are there. And if you don't understand that, when you're provisioning certain roles into your cloud and you're giving them that permission, you may be allowing them to lift disks and make them public URLs. Probably don't want to do that, right? And so there's some things you need to understand as you go through and build cloud that is different than on-prem. And there are some certain ways where your old school ways of protection may not work so well in cloud. Everybody's going to talk about attack chains. I suspect in the next 3 days, you're going to hear about attack chains a lot. We don't need to focus on those too much. But the reality is in cloud, every step of the attack chain has additional vectors you need to look at. And so I started the simplest part of reconnaissance. You know, reconnaissance used to be a lot of, describing networks and understanding what machines were there and then trying to get on that endpoint and then describing where it could get to and get to the next point. In cloud, there are these great API calls you can have that not only can describe the networks that you're on, they can describe the identity you have, they can describe other identities you might want to get to and what permissions they have. And so there's all of these kind of low-level list describe functions that you can use for reconnaissance that you don't need any network access to do. You can do it all from Sandbox, which is quite nice if you have the right access key for doing that. And of course, as people actually do infiltrate and get in, Now there's all these really interesting ways to do things like laterally move between the environments, because you don't necessarily need a network connection. You can just use an identity that can jump a trust relationship. And now you can get to that other point. You don't need to necessarily copy the data out over a network. You can just sync the data to a different cloud account and then extract it from there. So there's different things you need to think about at kind of every point in this attack path as you're doing this. And of course, the impact is the same in the end. Somebody's going to basically, destroy your data, copy your data, do something to your data. And so if you have some million paths in your networks, in your cloud, and you want to figure out, how am I going to prioritize where to start fixing this problem that I've created? The best thing to do is to really understand where those crown jewels are. And we've been talking about this for 20 years. We'll say, okay, out of this entire environment that you've created, where is the most sensitive thing that if that was lost tomorrow, you would have to shut the doors of the business, right? And you will put an infinite number of controls around that and try to protect it. And so if you can identify that in your cloud properties and know where that is, it gives you a starting point to start to build this out. And I always like to use this really simple analogy. When you were a child and you went to a diner, there was a placemat in front of you and there was probably a maze on it, and you had to get strawberry shortcake to the strawberries in the middle of the maze. Happens all the time. Your kids are going to get at it. And if you do it from the starting point of this, you keep running into roadblocks. You fix this problem and you hit a roadblock, and you fix this problem and you hit a roadblock. And that's what the attacker does. When they're from the outside looking in, they basically say, oh, I found a way in, and then they hit a roadblock, and they found a way in and they hit another control. But you have a benefit. And your children learn this when they're about 4 years old. If you start at the middle of the maze and work your way out, it's almost a straight path to the outside. And the reason is similar when you actually start to prioritize your risk. If you start with the most important thing, and you can actually understand every single thing that can access that in every possible way it can be accessed, and then you understand all of the ways that an overprivileged identity has access to that, or a toxic combination, which we'll talk about later, has access to that, or whatever it is, you can start to build out all of these controls. And at the outside, you will find that there probably are vulnerabilities exposing machines which have ways that they can laterally move to get access to all of these things. But you probably have a million vulnerabilities sitting on all of these machines. But if you start at the center and work your way out, the number of them that you have to actually fix is substantially reduced. And if we go back to cloud, remembering that we have a CMDB that can give us all this data, we can actually get the details of all the vulnerabilities. We can get all of this information. You can build a really complete picture of what's going on and work your way from your most sensitive stuff out to prioritize this. And so this is where we spend a huge amount of our time doing this kind of research and analysis. Now, what changed the game in cloud where, all of a sudden some breaches started to happen that were quite concerning? And this is, we start with the Capital One breach. Everyone knows that one really well, but there's lots of other ones. What happened was a lot of our identity governance process that we used for people drug along with them to cloud and didn't realize that there was a whole bunch of identities that were being provisioned under the covers, given a lot of rights, and no one really realized they were there. The attestation process for certifying a serverless function that lasts for 30 seconds doesn't fit into your SailPoint workload when you only ever attest thing, or whatever that word is. You only do it every 6 months, right? It doesn't work when it's only 30 seconds. And so when you look at this, what was happening in cloud, and there's some great stats here, 95% of the non-human identities, the actual workload identities, the actual identities that are part of your automation process, those types of things, only 3% of those permissions, remember there's 37,000 unique ones, they were given basically way too many of them, and they only used 3% of what were granted, which just created this very wide open scope where it was way too easy to laterally move within these environments. And I'll use the IBM statistic, 81% of breaches used an identity as part of its exploit is just doing this. And so you have all of these kind of non-people identities moving around that are kind of changing the game and how these attacks move and how they laterally move. And I have a lot of financial customers, and I've gotten to know the cloud operations people at these financials very well over the years. And of course, financial companies are known for having phenomenal regulation and phenomenal controls, and they do a very, very good job of it. But I would sit with the cloud operations people and we would laugh that, we've done such a great job at locking our cloud down that our own workloads inside the cloud can barely get to our cloud. They have to jump through so many hoops. Yet if I had the service principal key in Azure sitting in Sandbox, I can get to the entire cloud. because it would just bypass the way that all of the controls worked with the standard old way that they were doing it. And so we had to understand, how do these non-people identities work? How does this happen in cloud? And so this is a simple example. This is an AWS example. There's similar ones in Azure and GCP, but it's interesting to talk about this. Generally speaking, when you build your environments, you have to give your development teams a playground. And in the world of enterprise networks, we did that by burying them 5 levels of boundary firewalls deep. There was a lab network, and they could build and test and do anything they wanted in their lab network. And no matter what mistake they ever made in the lab, it didn't matter because it would have never been exposed in the public internet and whatever. So we have sandboxes. And then we had in, these production environments, rigid controls, and they were sitting directly on the internet, because now you've got this workload that has to serve the world. Maybe it's a healthcare app where somebody has to make a claim, an insurance or something like that. And the rules around that production environment were very, very stringent, and you wouldn't typically find any access from the lab environment into that. On top of that, you would never be able to allow the firewall admin to make changes to that environment without a lot of approvals. And so this is what happened to me. This is one of my first experiences in cloud in a mid-tier insurance company, and they were a good customer of ours. And we'll call them the cloud operations or cloud security ops guy came to me and said, "You guys are telling me there's a false positive here. You're telling me that the outside world can get into my," it wasn't semi-production, it was like their test environment. And that's clearly not true. We have compensating controls for this. It's like, well, what's your compensating control? This is a SQL database that can be accessed from the internet in your cloud. And he said, "Oh, well, it's limited to a single IP address." Like, okay, that seems like a control, but why is that allowed? He said, "It's fine. It's the developer's home network, and they've got it locked down to that, and that's how it is." And I say, "I have a question to pose to you. I want you to go to your firewall admin right now, and I want you to ask him to take my home IP address or your home IP address and poke a hole all the way through to my laptop so that I can get to my SQL server on it and see if he says yes." And the guy kind of sat there funny and said, "Yeah, he's not going to do that. That's right. But that's what you just did in your cloud. You basically allowed a home IP address all the way into a database." And say, by the way, in 2003, when SQL Slammer happened, we stopped doing this. We didn't put SQL databases on the internet anymore. Right? You can't do this in cloud. Now we say, what if we take the network away? Well, this is what happens when you take the network away. In the Sandbox account, you will overprivilege everything. You'll give everybody admin. You're like, it's a zone, it's fine, everything's controlled. And in production, you will have these zones as well. But what will happen is there will be a step in the middle of this that allows a transition. And it's usually caused by some operational role. So something that's crawling through the accounts to look for things. And what will happen is that there will be a line drawn from the Sandbox account into one of these other accounts. And from there, they'll be able to jump roles, and they will finally get to a place where that role can get into the production account. And you will have an active path that goes through this from here. And whoops, there was not one more build. I guess it's just really light on that screen. So you might be able to see the dots that go through here. And this is a pretty common pattern. When we work with most customers initially, we will find that there are certain places with certain operational roles that are under lockdown and cause these bridges to go from one point in your cloud to another and overexpose these. And this is what an attacker uses when they actually want to get into your production environment. They will come in through the sandbox, they will weave through things, and they will end up in production. So this is what we spend a huge amount of time doing. Now, what's really interesting as we do this, and again, if we think about connecting all of these dots, we actually put all of this data in a graph. And I love graph databases, and I hate graph databases at the same time. They're phenomenal, and they have great purposes, although they suffer some interesting query scale problems in certain scenarios. But if you think about what we're doing here, and we're taking all of these individual permissions and we're mapping them out for every identity. So this identity has these permissions, and then it can jump over here and it has these permissions. And then we take every workload and we look at the vulnerabilities. Another great thing about clouds and vulnerability are you can actually see all the vulnerabilities across all of the workloads without ever installing an agent or ever using a network to connect to them. It's phenomenal. It's the first time you've ever been able to do that. Using some actual cloud native technologies, you actually snapshot the workload's disk. You then mount that in another machine. You basically go through it, find the vulnerabilities, and then you just link it back in the graph back to the originating machine. So it's a great way to actually get a full footprint of all the vulnerabilities to them. Once you've done that, though, you can now start to see all this lateral movement across here, and you can understand that. And you basically from here get to understand these vulnerabilities lead to paths that actually get you to that most sensitive piece of data. And it's kind of like an automated red teaming exercise, right? So if you actually think about this, normally we pay red teamers to go in and they find the soft spots on the outside and they laterally move, and they always call us at the end and they always find something. They're very good at it. But this is kind of like doing that. And I always suggested that, people that have a system that's mapping all of this, you should give this to your red teamers up front. Say, here's all the soft spots, right? Just start here. You can laterally move through all of these points, because it really drives home the areas that you need to focus on to protect that most sensitive data in your given environments, and from you do that. So look, there's some interesting solutions to this across the board. One of them, of course, is this getting the complete picture. And I think as people move from data centers to cloud, there was this opportunity that happened where you could get visibility for the first time. We have products that do that, but even if you use open source tools, there's great ways to get visibility into everything that's going on in these cloud environments. And, I spent 20 years in enterprise data centers, and never once did I have a scenario where I could tell you everything that was running at any given second in time, let alone every network connection it had, every identity that was provisioned to it, and what it was doing at that given point in time. Never before. And so in cloud, you really do have this massive opportunity for transition and transformation in terms of seeing what's actually going on with your workloads as you're doing it. But you got to prioritize the work. We've known this forever. I don't know how many vulnerability teams I have worked in that have had, millions of vulnerabilities that they're triaging in any given point in time. And that's pretty normal, actually. Here's where I get a little bit concerned as people move from data centers to cloud. They use the same way of prioritizing their vulnerabilities in their enterprise networks as they did in their cloud networks. And because of that, they are almost completely unaware of some of these cloud native ways of doing lateral movement, cloud native ways of doing reconnaissance, cloud native ways of doing this. And because of that, the actual prioritizations of the vulnerabilities may change slightly. You won't see them the same way you did just by, applying business logic to those vulnerabilities as we've done in the past. And so I think prioritization, by starting at that most sensitive point and working your way out with these very technical maps, is a great way to do that. We actually find, ourselves, we use something called risk amplifiers. We use that to actually prioritize all these risks. I think if you look at some of the great posters that are out there, and some of the work that was being there where they were using attributes to basically, drive different features of different machine learning models, very similar technique. And again, anyone who has not looked at the posters yet should go out, look at all the posters. They're great. And certainly talk to the grad students who created those. They're spectacular. And my last one is always, start at the end of the maze. Start at the end of the maze. It's really easy to get to the front of the maze. So that's what I was going to kind of leave you guys with today. I know we only had 25 minutes, and I'm 21 minutes into my 25. I have 4 minutes. I would love to take any questions from the cloud that you guys want, and then we'll get you moved on with your afternoon. Any questions, guys? In the back. The microphone is moving for the people up front. It will arrive shortly.
Hi, thank you for the presentation again. My name is Kwesi. I'm from CIC. So you mentioned about the risk assessment with regards to identifying the most, the key element within your system. So I'm pretty sure it has to do with something like functionality, for example. My question would be based on what criteria, or is there a sort of a objective criteria that you use to identify the most critical, item within your infrastructure? Because you can have situations where a client might assume that this might be the most critical, probably in terms of what it serves, in terms of revenue or something, but then there might be something pretty much ignored that would be the key one. Thank you.
Yeah, look, there's several criteria that we use. Some of them are the classics. Let's say we're starting with a vulnerability. They're going to be your classic, CVSS scores or some corrected version of that score, right? That tells you how critical the vulnerability is. Then you're going to look at the exposures, both inbound and outbound from a network perspective. You know, can you get this thing from the internet somehow? Does it have access to broadly talk internally? So you're going to use those. You're going to look at the identity that is provisioned with, and can that identity get to other permissions, which maybe could cause it to self-escalate within that infrastructure, rather on the machine or in the cloud. And then, of course, you're going to use that, you know, the concept of that sensitive data, right? If it gets access to the most sensitive data through any of those paths, and that increases it again. And you use that by, you know, again, creating this amplification effect on that given vulnerability. One thing that's really interesting about cloud is we have these customers that have these phenomenal golden image processes, and they basically have shifted everything left and they believe it's all clean, right? We checked it in development, there's no vulnerabilities, everything's fine. And what we discovered in monitoring a lot of the cloud stuff was we ended up changing the vulnerability footprint, because what was happening is they were using we always call it a cocktail. There's basically a machine learning workload. Maybe they're spinning up Hadoop and they'd use it using a certain base image, and then they use a script on top of that that updates it with a bunch of different, you know, machine learning algorithms or whatever, and that brings in a bunch of dependencies. And by the time it actually executes, the thing that was the golden image is no longer the thing that's running, because of all this happening in the middle. And so by having that kind of real-time visibility actually allows you to see and change some of those risk amplifiers based on what's running versus what was kind of built in development. So anyway, there's at least few other ones in there too, in terms of how we actually categorize that. I see that I am after my time and the hook has arrived. So again, thank you guys. It's great to see some familiar faces.